In the year 2525, if man is still alive, if woman can survive, they may find.
Hello, my name is Rod Kowicki again. Anyways, my videos are getting to a point to where I'm trying to explain the burden of the theory of relativity. A lot of people say, well, it has to be rewritten, it has to be reinvented. In 1943, a scientist, lead scientist, discovered that Einstein's theory was wrong. They were all based on the speed of light, and they found out that the universe was expanding, and it was expanding at a speed faster than light. Einstein's theory are based on everything. The universal speed limit, which is the cosmological constant, is the speed of light. That means that the universe is, it's got a stop sign on it. You can't go faster than the speed of light, travel-wise. SRT, the special theory of relativity, was originally a communications theory, meaning that it had to do with light and sending messages, sending messages through a wire, and now we're wireless. And the speed of light was a limit for that, and they wanted to know how they could boost the signal to make it travel faster. Well, Einstein, in his time, when he wrote SRT, Special Theory of Relativity, in 1905, believed that the speed of light was the holy grail of the universe. The speed limit. That's it. We can't boost the signal faster than the speed of light. And that's basically what everything was measured upon. And they're still trying to find a way to boost a signal. But what Einstein also did is he wrote in his special theory of relativity that that's the fastest you could travel. But in 1943, like I said, it was discovered that the universe was expanding faster than the speed of light. So how do you measure a speed limit for space? Isaac Newton measured free fall at 9.8 meters a second per second for free fall. Everything in the universe is free fall. Einstein tried to take that free fall and put it in space. And he added attraction, and he added time dilation, it slows down. And basically, what I believe, is it might slow down in essence to very little and not as much as it doesn't stop. Time, I don't care where you're at. Einstein's theory goes on the idea that if you're traveling at the speed of light, 1 second per second, and you have you launch from a planet, and you travel at the speed of light for each second, the time slows down to 0 on the planet in the comparison. And I think everybody knows that's really not true. You know, if time, which is not time, but the speed of light, which everything is limited to, a universal speed limit, it's 1 second per second. That's how they measure the speed of light. Okay. That means each second, the distance, the travel distance, is another 186,000 miles. And each second. So if you got 5 seconds, that's 5 times 186,000 miles, right? Now, his theory on time travel says that if you compare that to a planet which renovates the same seconds, that at the speed of light, the ship is traveling, time on the planet stops. It stops. It stays at 0. Can you imagine a clock staying at 0? But imagine this. You're on the planet and life goes on. Everything doesn't stop. Even in the comparison. It's always been, it seems. His theory is based on it. It seemed. It would seem like. It would look like. But, and a lot of people take that for reality, which makes it an illusion. Okay, you travel at the speed of light, time stops. Time don't stop nowhere. Because time is not attached to anything, it's a measurement. And people just don't seem to understand it. So, if you're traveling in a ship for 5 seconds, you travel 186 times 5 times. People on the planet, if 5 seconds go by and they go 1.8 miles, then they go 1.8 miles for 5 seconds. And that's how far they went. Because that's what they're traveling, and that's what you're traveling. There's no change in this dilemma of the speed of light and local time, which is planet time, let's say. It's called local time. Look at it this way. Einstein tried to take a body, a human body that can run 30 miles an hour or 25 miles an hour, consistently, like for 5 miles or something, right? And put another person next to it that traveled at the speed of light. Still, you look at it. The guy that's running 30 miles an hour, 25 miles an hour, in 5 seconds runs a shorter distance than the guy that can travel at the speed of light. But time doesn't change. The seconds never change. The clock doesn't change. Now they have incidents where the clock slows down. Okay, when they measure with GPS, and if they didn't get it right, the GPS mapping would be off, for 6 seconds, they said, or something. But when you look at that, the clock that they measure the mapping on a GPS is not under attack. It's not on the clock is not under attraction. You know, and they says, well, the difference is about 6 seconds. But you got to also look at the idea that the Earth is moving. It's got its orbital rotation, and that motion is 18.6. So you take 6 seconds, I think that they said. Divide that into 18, and you get what? 3 times. Meaning that 6 seconds would be 1/3 value of the 18.5 or thereabout. So they don't map it, in a 3-dimensional. You can't map a 3-dimensional object. You can't see through it to the other side. So the mapping is like almost 2/3. You can probably look at a 3-dimensional object and see about close to 2/3 of it, but you can't never see all of it. And then from the distance, you might see even the top, and 1/3 or 2/3 of its shape, 3 dimensions. Its shape. My videos have to explain why the speed limit is not constant. A lot of people say, well, the expanding universe explains all that, but even Edwin Hubble did not go into the detail of the difference. Nobody has. The difference between Albert Einstein's mapped universal constant and an expanding universe. And that's kind of what my theory is based. It's also based on the gravity content. See, Isaac Newton knew that an object fell at 9.8 meters a second, but didn't know why. He only knew that it did. See? But he didn't know why. And when you go through most of our discoveries in physics, you could hunt for an answer. And I think I found that answer. It's in my other video, the one I did before this. In references, I don't think a book has been written on the content of gravity and based on exactly what it is. Being a mathematician means you're in a laboratory and you're doing all this testing. I just do literature research. But basically, and I write books. But basically, I discovered that if they took these elements that exist, that we know more about than in 1667, and probably 1905 and 1915 when Einstein was doing his research, that they should have already came to this conclusion of how to define the elements of gravitation. Why it does. Not that it does, not an expression of mechanics, but the expression of its chemistry. And I wrote a lot of that in my book, the chemistry behind the gravity state. Both Earth's planet science and space. And one of the dilemmas is the speed of light. The speed of light is explained as a limit that equals space. Space has a velocity. It has a speed from everything that they know. And Einstein once said, well, that speed is the speed of light. So, because of that, these certain things would happen. Time travel. The idea that traveling at the speed of light, it would seem that the two planets, if you look at two planets while you're traveling at 186 miles a second, the comparison would be planets are very close together. But in reality, they're not, But you get tripped in it when you read it. It's a type of literature, And so Einstein, even Einstein tripped out because he wrote about of a light ship, or if I traveled in a ship at the speed of light, the same speed as light did, what would happen? And people take that seriously, that time travel is possible. They try to elude that the time travel. I'm not saying there isn't, but I think there's more involved than what Einstein said, what anybody said about time travel. That the idea of it is superficial, But we're not. We don't have that knowledge. Einstein did not have that knowledge. You can't stop. If you could stop time, you could stop the universe. And you can't stop the universe. In a little ship? Come on, man. Okay, you're in a ship traveling at the speed of light, You're not connected to anything. There's no infinite mass because there's no interaction of energy in space. So it's impossible to time travel under those conditions. Trying to make space. We have the black hole theory, and there's a few different analogies about black holes, but if you read any of my books, you discover that I talk about something called a embryos. An embryos is a cosmic egg, and I believe that these eggs were formed after the Big Bang, and then over time again after the Bang, that this was the bangs. They were called little bangs. In another book that I've written, that I have heard about. I read some of it. It's called Shebang. That the galaxies, were individual cosmic eggs that exploded and created individual galaxies, different forms of galaxies, different colors, different densities, planets, again, inside the galaxies, And you can't change what is superficial in creating it. You have to be the creator of something to make it, to work at mechanics with it. And we didn't make the universe. We evolved through the universe, but we did not create it, and we can't change it. And time travel under those conditions, Einstein's condition, is impossible. It's superficial. Time, it doesn't slow. How can you slow down a clock That's like saying I throw a rock here in the water and over on the other side of the planet, the water jumps up. There's no connection. There's absolutely no connection. And the connection in space, bending space, planets warping space. Look how big of a planet is. And then we make a little ship, and we're going to do what planets do at rest. And the only reason they're doing it is because space is making a move. Space is what's expanding, which is moving. And it's making everything in it react in a certain fashion. And so nothing in the universe is at rest because of this. And if you look at my earlier video, you'll discover why and how this type of gravity actually works. You know, they don't know what the element of dark matter is or dark energy, but the idea that there's matter and space as a grid or space field, we reside in it. That is the effect of its expansion, making everything else, all matter, react and fall. You know, space is actually creating the push for matter to move. You know, and that's how the universe works. So we're talking about time travel. In essence, time travel and relativity is a comic book. It's actually, I don't know if anybody ever even read a comic book about time travel or anything, but I know Hollywood and all them writers in Hollywood did write books about it. But we're talking 100 years ago of what they thought that they could bend space with the ship traveling at the speed of light. Even if they do, the essence of that interaction with space is very small. The ship's very small. It's like a piece of dust compared to a car or something. You know, there's nothing. There's nothing. And you need that interaction between all the energy to make Einstein's theories work. And in space, there is none. So in essence, there's no gravity in space. And the gravity on Earth, relative to trying to time travel on Earth, is impossible because 186,000 miles a second is going around the Earth like 3,000 times. You know, ain't nobody gonna do that. It's too much distance and too fast to have any reaction against the gravitation of Earth's gravity. It's too small. And in essence, the comparisons between planet gravity and space, the big G, the little g is measured with free fall. So you have free fall, which Isaac Newton is, but we also have constant acceleration. And when you measure the speed of light, you have to measure the contents of either one of those, or both. And the second one has not been done. It's only the content of free fall, not physical. You know, it's like putting your foot on the pedal. You know, you have a car going free fall and it's going down a hill. You know, and you got the same car, but it's got an accelerator pedal, and it pushes with acceleration. And the speed of light is measured differently in both of those cases. But only one of them cases has been mathematically defined. And Isaac Newton was the first, and everybody else has followed since. So, how gravity works relative to the speed of light on Earth is indifferent than what we think it is. Because there's, two ends to the river. The river branches off. There's different ways to look at it. In fact, there's a third way, and that's in my book, my next book. Another way to look at gravity in the essence that it defines a less acceleration mass than Isaac Newton measures. In other words, Isaac Newton, you take a free fall of a ball, a 1 pound ball, and you drop it off something high, like he did, the Eiffel Tower, and you measure it, but actually he used a hill, I think, and they measured it, different sizes to see, and they both got to the line at the same time, and they couldn't figure that out, One's bigger than the other. It should have more mass. Why are they the same? Based to acceleration. See? But they never could figure that out. Well, if you look at it, there's a difference when something's in motion and when something is not. The high frame of traveling at the speed of light in space is traveling through 0 point energy. A vacuum, zero. So there's no energy to interfere with the ship. Now, some people say, well, the ship itself generates so much energy. But that's smaller. That's on a smaller scale. And it's like taking an ice cube, which is as big as an ice cube, and using that to make it rain, each drop is smaller and lighter than all of that, and the water content that is frozen in this cube. Infinite mass is the cube. It turns into a cube. But if there's no energy acting on it, then that cube weighs nothing, or very little, like I said. It's like comparing a room full of water compared to an ice cube, basically. Okay. So when we're in motion, we're not grounded. We're not at a point to where we could say that it stopped, and now weigh it, So we get a certain weight. That's a total weight of an object. But when Isaac Newton measured gravity at 9.8, it was for both objects. Now, when you're in space, both objects, there's no energy acting on them. I could see that they all both act the same way. But now we have gravity, and they still both act the same. Why is that? It's because they are weightless. They have little attraction that is measured by the atmosphere, energy in the atmosphere, and not grounded energy. That energy has not been grounded. So whatever the energy is in that atmosphere, which is smaller than the energy when it's grounded, the totality of being at rest, and it's mobile. It's random. You don't know what it is. There's more energy over here in the atmosphere than there is, and so there's going to be a difference in how much energy is involved. There might not be enough energy to measure the difference between a 1 pound ball and a 2 pound ball when it's falling. But, I mean, it's very small because the energy content in the atmosphere is the same. The higher you are, the less energy is. Like you could look at it this way. The higher you are, the less air there is. It thins out. So does energy. And that's why free fall is measured that way. The ball has to reach 9.8 before it can be measured. You know, at that content. You know, like the first 9.8 meters, let's say. It might take 5 of the meters before he hits 9.8. But yet, a 1 pound ball and a 2 pound ball both fall at the same time. It's called the theory, it's a hollow theory. That means mass is the structure of atoms making up something, but they contain no energy. So they call the mass hollow. Now you take that mass and you put it in an atmosphere by itself and let it go, drop it. The energy content of each ball is the same. It's not how much it is, it's what its frequency is. And it would seem that the ball, when it falls, would change frequency, but it doesn't, it can't, because that's the frequency it is until it reaches the ground. If you want to get really technical, it's hard to understand, but that's kind of how it works. Now you might say, well, he's just writing a video saying that time travel, it ain't, not in this day and age, not in 1,000 years, time travel. But yet, we are meant to believe that time travel is possible, and this is how you do it. It could be mapped. I could say it could be mapped. You know, and Einstein's theory could be a logical direction to how to do that, but it isn't the formula. That isn't the formula. There's too many, you know, like I said, there's 3 ways to measure gravity, and besides that, the speed of light isn't constant as we thought it was. And it will never catch up with the universe, because the universe is growing and the speed of light never changes. So you can look at it like that. Light will never catch up with the end of the universe. Besides that, the universe is 3-dimensional. Anyways, I wanted to put this in there, the mathematical errors of Albert Einstein. The content of his greatest blunder. My name is Rod Kowicki. I thank you. And read my books. I have 5 books out there. I'm working on another one. It's how compatible with everything else is out there. You know, I travel, you know, it talks about just what I'm talking about. You know, a second is a second, no matter where you're at. You know, it might look like that, but it's actually seen. Or if you want to look how the picture looks, you know, you could put a cat over there. You know, but in reality, the mathematics don't line up. So again, I thank you. My name is Rod Kowicki, and have a good day. Without realizing it, you can see where his theory, if not for faster than light, the green shows how universal constant works in SRT theory. In reference to Einstein's idea and this diagram, the speed of light governs space and light. It's all based on light, and nothing can travel fast unless there's some more definite space, or the density of space is the same as the speed of light. But neither are true because of the FTL theory. It may seem like he says, actually, I think I read once where he said it would seem like two planets are close together, observing, but what he does is elude the facts, the mathematical facts, that's not really what happens. The facts are based on the mathematics, and the mathematics don't meet with bending space, time travel, time dilation, and all the effects of gravity that work with planetary gravity. Planetary gravity and space are different, even though they have a university. And that is FTL, faster than light. That means space is everything, includes the whole, everything in it. And everything you observe about space, or the big G includes the little g. So the difference is the density of the planet, which is its energy, and the action of a falling mass. But still we have a coincidence. Random particle mass in space, empty space, where there's zero energy, and randomness in the motion of a falling object in space. They're at random because they're not at rest. The same as in space. I hope you like my theory. My name's Rod Kowicki.